Ice cream and emulsifiers. And this is why when you make ice cream at home, you're boiling milk yourself. Number two, egg plus, and let's just put yolk in parentheses, plus the sugar. And then the last, the cream and the whisking. The fundamental point that makes store-bought ice cream worse than homemade ice cream is because homemade ice creams will always have natural emulsifiers if you make it this way. But most store-bought ice creams will not have a natural emulsification process. If these are our three reasons, let's start with point one, boiling the milk. It's got proteins, it's got fat, and let's also say there's air. And to symbolize these four different things, I think H2O would symbolize water, empty circle would be proteins, a filled circle would be fat, and air would be a star in a normal state. We'll have their fat. They're gonna have, and this is the fat, so we're gonna color it in. They have the little proteins everywhere, and they're all around this fat molecule. And then around, and these proteins, their job is to keep this fat in place. And around those proteins will probably be some water. When you're whisking, what you're doing is introducing air. As you whisk and whisk and whisk and whisk that cream or that milk, what you're doing is you're replacing the fat molecules with air. And then you're just gonna kind of get this acting as a way for the proteins to get together. And this is whisking without the boil. So let's say you boil first. All you're doing is, if the proteins are wound up like this, what's gonna happen is they're gonna denature, just break down. So after you boil milk, you're gonna have your water still, right? And maybe if you foam it up, there'll be some air, but you're gonna boil the milk, there's gonna be water, and there's just gonna be fat. And if you let this sit over time, that fat is gonna separate out. Once you boil it, and then you whisk. Now, if you let this settle out, like let's say instead of whisking it really hard, you just whisk it a little times, once or twice, and then put it in the fridge, your mixture is going to separate out really badly. So if I only whisked it a little bit or didn't put much effort into incorporating the mixture, the probability that you're going to get less of that creamy smoothness is much low. So you whisk and you whisk and you whisk and you whisk and you whisk, so that until you get that beautiful, just amazing, silky smooth texture. This is how you get that creamy final product. And this is just only talking about the milk and once you boil it, what happens, etc., etc. But after you add the cream and also add the sugar egg, which we'll talk about next, makes the sugar into the egg yolk. And yolk is very important. Whites, in my opinion, are pretty useless. Whites have like 90% water. Egg yolk, the good part, it's like 50% water. When it comes to proteins, it's like 9%. Egg yolks have like maybe 15 to 20% protein. Let's say fat, these are sugars. There's like, let's say less than one, less than one. Whereas the yolk has like probably 25% fat. And then on top of that, they have 5% sugars. We should also say vitamins, minerals, and naturally occurring lectin. So, oops, I think there's an I here. Some background information for those of you not in the know. My education is actually in chemistry. So let's draw out lectin because, oh my goodness, not drawing out lectin at this point would be a mistake. Hydro means water. Lipo means fat. Think of a liposuction, and hydro, think about hydrotherapy. Say philic means to like. So these two things like each other. And phobic means they don't like each other. Not like. Now, you see these beautiful long tails here. This is like, let's call this tail 1. This is the second tail, tail 2. These tails are long. They get in the way. Water does not like it. It's a chain of carbons which are all bound up with hydrogen around it. So there's nothing that can really attack this. This is what is called nonpolar. All nonpolar means is there are no positive or negative poles that are formed in that part of the molecule. You know, they're chill. And another really basic chemistry principle to keep in mind is likes attract like. So things that are similar to each other are attracted to each other. Things that are not similar to each other would not be attracted to each other. Polar, non-polar. So, is that you're going to have one side of a molecule that's positive, another side negative, and then that will create a momentary interaction. All non-polar means is you have just two molecules that are in the middle. There isn't this like strong interaction. They're just kind of like, book, we're friends. Whatever. Let's move on. The reason I'm bringing this all up is because we have these two chill non-polar chains. But then over here, what do we have over here? Is that a negative sign? Oh, is that a positive sign? We have this negatively charged part of the molecule and this positively charged part of the molecule. So what ends up happening is water, which is, we get our and look at what happens here. We get, this is water by the way, we get charges in water itself. Also look at sugar. So as sugar is attacking this polar side of the molecule, we have fat. So when your fats look like this, and the lectin fat looks like this, these things will attract. They're going to attract because they are similar. The same way, polar molecule to sugar, polar molecule water will be attracted to the polar side of lectin. The crux is we have water, which is polar. We have fat, which is non-polar. And we have sugar, which is usually polar. So the sugar and water will mix together really easily because likes, similar things attract to each other. So likes attract. Polar, polar, water, sugar, these will mix. And we see this very easily in simple syrup. You mix 1 cup of sugar, 1 cup of water, you get simple syrup. Fat and sugar. This is the issue. If you mix fat and sugar or fat and water, it will separate. The one example we gave earlier was boiling milk and leaving it on the stove to cool. The fat will separate from the water. You'll get that fat layer on top and the water layer on bottom. And that happens because, let's remind ourselves, when you boil fat that's in the milk, the proteins get denatured. So you're just left with water and fat. The fat does come from the milk and the cream, and the sugar egg mixture will also have fat, and also it'll have the emulsifier. It'll have the lectin. And because it has the lectin, the fat from the milk and the cream, if incorporated, if mixed correctly, will start sticking to the lectin. And it's really because of the naturally forming lectin in the egg yolk that you get that final silky smooth texture. You get the final sugar egg mix. This sugar egg mix is what builds this strength. When I say strength, I mean when you lift up a spoon of ice cream, it holds its shape. It gives its smoothness. So when you eat it, you don't actually feel any of the individual particles. You don't feel the fat. individually. You don't feel the sugar. And the last thing about the sugar egg mix is that it provides this slinginess. Now, I think slinginess is a made up word. Without the right sugar egg mix, what you're gonna find happening is you'll get ice cream, but it's just gonna taste much more like frozen yogurt that's churned. This is point 2, and this is the most complex point, because if you do the sugar egg mixture wrong, if you overcook the eggs, you're not gonna have the lectin molecule retain its shape. All you're doing is warming it up slightly so that everyone gets some time to meet each other. You want the fat molecules in the egg to get some time to meet the lectin. You want to get your massive amount of sugar, and there's a little bit of sugar, but there's a lot more sugar in when you're adding it in. You want to give your sugar time and a little bit of warmth, a little bit of coziness to find its way to the polar section of lectin. And that is the only way you are going to get a really smooth ice cream. You cannot do this step and just add emulsifiers. You can add emulsifiers to some fat, some water, and some sugar, and get ice cream. Eggs, maybe. You don't even necessarily need eggs for this type of ice cream. It's just sad. But this is what most modern producers do today, because, man, like, you can just throw this in a pot, get it churning, and you'll get ice cream out. When you do it this way, you're actually not gonna get the texture. And when I say the texture, I mean that very specific interaction in egg yolks between the egg yolk fat, the lectin, and the sugars. This creates the texture of your ice cream. This is the whole point of sugar into eggs on low heat. Low heat. Point 3, adding cream. So I very specifically put aside the cream. So let's just do a quick drawing. This is the cream box. Cream. All right. Cream is pretty shelf stable. Like, fat is pretty shelf stable at room temperature, but it just lasts forever frozen. So when cream is frozen, and they aren't moving much, and they're kind of just like eek, 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 fat, 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 fat. And then there's also some water. And you'll see this in cream bottles where like a lot of the fat will reach the top, and you'll get this layer of cream on the top, and then there'll be like a mixture. So this will be liquid, this will be solid. So in not frozen, I like, let's say like 40 degrees Fahrenheit cream. I don't know, what is this in Celsius? So first thing first, you're gonna actually want to shake your cream bottle. And that's to get the solid stuff on the top and the liquid on the bottom mixed together. And I pour out my cup because I don't want to spoil the whole thing. This is 1 cup. And I just let it sit on the counter for roughly 20 minutes, maybe up to 30. In this post environment, if I drew the fat molecules this close together, like, they're so close together, but like they just like have a little bit more breathing room. It's not this like uniform at all, but like, you know, there's like a little water here and there. But it becomes a much more even mixture. If you don't shake the cream and then let it sit, I have found that the layers separate much more within those 2 hours. So I found you'll get the cream layer on top, you know, you'll get the sugar on the bottom, or some type of sugar syrupy thing. But if you don't mix it the right way, and if the cream is too thick and cold, the cream will just stick to the cream and everything else will separate out. And more in the fridge because of crystallization and other things, but that's a whole other story. I always add the cream to the boiling hot milk. Then you get cream plus milk mixture. Why do I add the cream directly to the milk before the sugar is added to the milk? The reason you do this is because likes attract likes. This 1 cup of cream has fat. The milk, as we talked about before, has fat. Fat plus fat equals fat. Cream and fat mix. This is when I add sugar yolk. And it's here and only here. Once you add the sugar yolk, I start going wild with the whisking. There are other reasons to whisk, but this is the most important time to whisk. And because yolk actually doesn't have that much fat. A lot of the eggs into the sugar. Almost all of the polar binding sites are filled. And a lot of non-polar binding sites, like up here in these long chains, are open. You prepare this wonderful fat mixture, cream and milk, then add the sugar yolks into the fat mixture. Because the sugar yolks are already an emulsifier that have a lot of fat tails just freely hanging around, waiting to get mixed. And with these free fat tails, when you just plunge it in that fat, almost all the fat starts surrounding the emulsified mixture. And if you whisk it real well now, you're going to get a real smooth mixture because the emulsifier is already primed to accept the fat. So I think this covers it all, you know. I'm once again going to go from the top. Wow, I started small and I got big. From the top, step one is you got to boil the milk. And the reason to boil the milk is to get rid of those proteins and get that fat out there, out in the world, meeting everyone. Because otherwise, fat in milk is surrounded by proteins. It can't go to social events. It has like little zits all over his face. The sugar egg yolks. The magic in the yolk is lectin, that is an emulsifier. The sugar egg yolk mixture, make sure that almost all the sugar is bound somewhere in the mixture, mostly to a lot of it will be bound to the polar site at lectin. But the egg yolks don't actually have that much fat, only 25% fat by mass, right? Almost all that fat will be bound up with lectin or some other molecule. But what that leaves is a lot of lectin's non-polar tails free. And lastly, the cream. The cream is so important. We add this cream to the boiling hot milk, which has denatured proteins, to get a fatty fat mixture called the cream plus milk. From the fatty fat mixture, which is still like 100 degrees Fahrenheit at this point, then we add the emulsifier, which has sugar bound to all of its binding sites, and the yolk, which has a bunch of other things too. You add that directly and you whisk it, and you get wonderful, creamy ice cream. Yeah, and thank you all for coming to Healthy Bharat Explained.